Hello everyone, and welcome to Dr. Karmanati's YouTube channel. I'm so excited to have you here today as we dive into a groundbreaking topic from a recent paper on RxEV titled Absolute Zero, Reinforced Self-Play Reasoning with Zero Data. You can find the link to the paper in the description below. If you're fascinated by the future of artificial intelligence and how it might evolve, this video is for you. I'd love to hear your thoughts. Drop your comments below, suggest ideas for future videos, give this video a thumbs up, and hit that subscribe button to join our community of curious minds. Let's explore this revolutionary concept together and see how AI can learn without human data. Today, we'll explore a fascinating idea from the paper Absolute Zero, Reinforced Self-Play Reasoning with Zero Data, published on May 6, 2025 by Andrew Zhao and a team of researchers. This paper tackles a significant challenge in artificial intelligence. How can we train large language models to reason and solve problems without relying on massive datasets created by humans? The authors propose a bold new approach called Absolute Zero, where a single AI model learns to generate its tasks, solve them, and improve its reasoning without external data. This concept could reshape how we think about AI's future, especially in a world where human-generated data might limit AI's growth one day. To understand why this matters, let's step back and look at how AI models, like the ones powering chatbots or virtual assistants, typically learn. Most models rely on a method called supervised learning. Humans provide them with massive data sets, think millions of questions and answers, or labeled examples of text, and the model learns by finding patterns in that data. For instance, to answer math problems, a model might train on thousands of solved equations. This approach works well. However, there is a problem. It depends on high-quality, human-made data, which is hard to come by. As the paper points out, such data scarcity raises concerns about scalability. What happens when we run out of good examples, or when AI surpasses human intelligence and human tasks no longer challenge it? The authors highlight a future scenario that's both intriguing and unsettling. Imagine a super-intelligent AI, far more intelligent than any human. Tasks created by humans might become too simple for it, like a college student solving kindergarten puzzles. To keep growing, AI needs a way to challenge itself independently. That's where Absolute Zero comes in, a method that lets AI learn through self-play, generating its challenges and improving without human input. Let's dive into how this works and why it's a game changer. Before we get to Absolute Zero, let's talk about the foundation it builds on: reinforcement learning with verifiable rewards, or RLVR. Reinforcement learning is a training method where an AI learns by trial and error, much like a child learning to ride a bike. The AI takes actions, gets feedback through rewards, and adjusts its behavior to maximize those rewards. RLVR rewards are verifiable, meaning the AI can check for correct answers without human supervision. For example, if the AI solves a math problem, it can verify the solution by checking if the equation balances. Recent RLVR methods have shown promise in boosting the reasoning skills of large language models. Instead of relying on human-labeled steps, like showing the AI how to solve a problem step by step, RLVR focuses on outcomes. If the AI gets the correct answer, it earns a reward. If not, it tries again. This zero-setting approach avoids the need for detailed human guidance, but it still depends on human-curated questions and answers for training. The authors argue that this reliance on human data creates a bottleneck. Absolute Zero takes RLVR to the next level by removing that dependency entirely. Now let's get to the heart of the paper. the absolute zero paradigm. The authors propose a system where a single AI model does two things simultaneously: creates its tasks and solves them. This self-play loop allows the AI to maximize its learning progress without external data. Think of it as an AI that simultaneously acts like a student and a teacher. The teacher side invents challenging problems, and the student side works to solve them, learning and improving with each attempt. Here's how the process unfolds. The AI starts by generating a task, a complex logic puzzle, or a math problem. It designs the task as hard enough to push its limits based on what it already knows. Then, it switches roles and tries to solve the task, using reinforcement learning to guide its efforts. If it succeeds, it earns a reward and moves on to a more challenging task. If it fails, it adjusts its approach and tries again. Over time, the AI improves at creating and solving complex tasks, building its reasoning skills from scratch. This self-play approach draws inspiration from how humans learn through play. Children often invent games to test their abilities, like building a tower of blocks and then figuring out how to make it taller without falling. Absolute Zero mimics this process, letting the AI explore, experiment, and grow independently. The paper emphasizes that this method eliminates the need for human data, addressing the scalability issue head-on. It also prepares AI for a future where it might need to learn beyond human capabilities, tackling problems we can't imagine. So why does Absolute Zero matter? Let's explore the implications, starting with scalability. Current AI training methods rely heavily on human effort. Collecting, labeling, and curating data takes time and resources. As AI systems grow more advanced, the demand for high-quality data will only increase, but human production can't keep up forever. Absolute Zero offers a solution by letting AI generate its training material, potentially scaling infinitely without human input. This could lead to faster, more efficient AI development, especially in science fields where AI could independently propose and solve new research questions. Another big impact lies in AI's potential to surpass human intelligence. The authors raise a thought-provoking point. If AI becomes super intelligent, human-created tasks might not challenge it enough. Absolute Zero ensures AI can keep growing by setting its own goals, much like a self-motivated learner. This autonomy could unlock medical, physics, or engineering breakthroughs, where AI might discover solutions humans couldn't dream of. Absolute Zero also has practical applications today. For instance, it could improve AI's reasoning in domains where data is scarce or expensive, like rare disease research or space exploration. By generating and solving its problems, AI could uncover patterns or insights humans might miss. Additionally, this method reduces the risk of bias in training data. Since the AI creates its tasks, it avoids inheriting human prejudices that might exist in curated datasets. Of course, Absolute Zero isn't without challenges. Designing a system that generates meaningful tasks and evaluates progress is incredibly complex. The AI needs to strike a balance. Tasks that are too easy won't help it grow, and functions that are too complex might lead to frustration and failure. The paper doesn't delve into the technical details, but hints at the need for advanced algorithms to guide this process, ensuring the AI's self-play loop leads to steady improvement. Another challenge involves validation. In RLVR, the AI verifies its solutions using clear, objective rewards, like checking a math answer. However, defining success becomes trickier for more abstract tasks, like creative problem-solving or ethical reasoning. How does the AI know if it's solved a philosophical question or designed a fair policy? Future research must address these gray areas by combining absolute zero with other learning methods. The authors also point to exciting future directions. Absolute zero could integrate with multi-agent systems where multiple AIs collaborate, each generating tasks for the others to solve. This could mimic how humans learn through competition and cooperation, accelerating AI's growth further. Additionally, the method might apply to robotics, where machines could learn to navigate new environments by setting their own goals without human-programmed instructions. The ideas in Absolute Zero, reinforced self-play, reasoning with zero, data open up possibilities for AI's future. If this topic sparks your curiosity, I encourage you to explore more. Start by reading the full paper on ARC. It's packed with insights into reinforcement learning and AI reasoning. You can also dive into books like Reinforcement Learning, an introduction by Richard Sutton and Andrew Barto, or watch online lectures on AI self-play, such as those from DeepMind's AlphaGo project. Follow the latest AI research on platforms like RxIV, or attend virtual conferences like NeurIPS to stay updated. The more you learn, the more you'll see how AI might one day think, create, and innovate, maybe even surpassing us in ways we can't yet imagine. What an incredible journey we've had today. We've explored Absolute Zero, reinforced self-play, reasoning with zero data, uncovering how AI can learn to reason without human data, thanks to a revolutionary self-play approach. From its roots in reinforcement learning to its potential to redefine AI's future, this concept challenges us to think big. I hope this inspires you to dig deeper into artificial intelligence. What do you think? Will AI soon teach itself everything it needs to know? Share your ideas in the comments. I read every one. Suggest topics for our next video, give us a like, and subscribe to keep exploring with me. Thanks for watching, and I'll see you soon.